All right, for this lesson, we are going to look at how to determine where functions are increasing and decreasing. And we're also going to use the first derivative test to identify where maximum points and minimum points occur on the function, relative maximums, relative minimums. All right, so we say that a function is increasing on an interval if for any two numbers x1 and x2 in the interval, that if x1 is less than x2, that implies that f of x1 is less than f of x2. All right, so if you have a function like this, maybe not like that. Let's draw an increasing function. Something like this. This would be x1, this would be x2, and then this would be f of x2, and this would be f of x1. All right, so the y value of this point is less than the y value of this point, and the left endpoint is less than the right endpoint. All right, a function is said to be decreasing on an interval if for any two numbers x1 and x2 in the interval, x1 being less than x2 implies that f of x2 is less than f of x1. So that would start high, end low. F of x2, this is f of x1 on the left side, and then this is f of x2 on the right side. So f of x2 is less than f of x1. All right, so how do you test for that? If f prime is greater than 0. So if f prime is positive, that's positive slopes. All right, then your function is going to be increasing. All right, if f prime is less than 0, so you have a bunch of negative slopes, then f is decreasing. If f prime is equal to 0, a bunch of horizontal slopes, then f is constant. All right, our first derivative test, let c be a critical number of a function. So remember, that means that f prime is equal to 0 or f prime is undefined, as we learned in a previous lesson, of a function f that is continuous on an open interval I containing c. If f is differentiable on the interval, except possibly at that point, because remember, a critical number can include where f prime is undefined at that point, then we can classify that point c f of c as follows. If f prime changes from positive to negative, all right, so f prime positive changing to negative, then that point c f of c is a relative maximum. Of f. And if f prime changes from negative to positive, so negative slopes changing to positive slopes, then that point cf of c is a relative min of f. All right, so that's what we're going to do on this problem. We're going to find the intervals where f is increasing and decreasing. We're going to identify all points that are relative maximum and minimum points, and then we're going to justify our answers. So that is the key to today's lesson. Finding all this stuff is pretty simple. Being able to justify it correctly to earn all of the points on our FRQ is going to be the hard part. Okay, we'll sketch a graph of our results. Okay, so all of this stuff, increasing, decreasing, maximum, minimum, anytime you see any of those words, you should immediately think in your brain first derivative. That's how you find all of it, first derivative. So we need to take the derivative of our function. Multiply by 3, so you just get x squared minus 2x minus 3. Okay, our function is not going to be undefined anywhere. Our derivative, is not going to be undefined, so we just need to set it equal to 0 and solve it. All right, so we have two critical points at 3 and -1. Okay, these are going to be where our relative maximum minimum points occur, and they're the only places where the maximums and minimums could occur. Okay, so draw a number line. Make sure you put your points in order. All right, and then we're going to plug numbers into f prime in between these critical points. All right, and I'm going to use the factored form. It's usually easier to do it in factored form. All right, so -2 Negative 2 minus 3 is a negative, and negative 2 plus 1 is also a negative. A negative times a negative is a positive. All right, let's go with 0. 0 minus 3 is a negative. 0 plus 1 is a positive. So negative times a positive is a negative. And then 4. 4 minus 3 is a positive. 4 plus 1 is a positive. Positive times a positive is a positive. All right, what does that tell us about f? Well, if f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. If f prime is positive, then f is increasing again. Okay, if our function changes from increasing to decreasing, that means there is a relative maximum there. And if our function changes from decreasing to increasing, that means that there is a relative minimum there. All right, that's all we needed to find. So we're going to justify our answers. I'm going to try to fit that in under here. So we have to write a sentence for each one of these. All right, so I'm going to start with increasing. So I'm going to say f is increasing on, and then we say the intervals where it's increasing. So it's increasing from negative infinity to negative 1. Okay, nobody agrees whether we should put a square bracket or parentheses. I've heard a couple people now who will argue very strongly for a square bracket here, that it is in fact increasing at negative 1. I always put a parentheses, and the AP exam doesn't care what you use. They're going to give you credit for either one. First of all, it's a little hard to tell whether a student wrote a square bracket or a parentheses, so it's going to be hard to take off or give them points for that. And secondly, there's textbooks that'll use parentheses. Our textbook uses parentheses, and there'll be other textbooks that use square brackets. So since nobody really agrees on this, they just say, we'll accept both of them. All right, so I like to use parentheses. So we have a parentheses, and then we're going to say and then our second interval goes from 3 to positive infinity. And then this, we haven't justified anything. We've just stated what the answer is. So here's our justification. Because, I'm going to abbreviate B/C, because f prime is greater than 0 on those intervals. Okay, that on those intervals is an important phrase. Okay, you could also use the word there, which I'll probably use in the future, but I am going to try to use on those intervals today because it's more specific. Okay, f prime is not greater than 0 everywhere. So if you just stop at f prime is greater than 0, okay, you're kind of implying that f prime is always greater than 0. And that's not true because it's not right in here. So you want to include on those intervals for that reason. All right, so our second part is decreasing. So f is decreasing on negative 1 to 3. Again, I'm going to use parentheses. And the reason is because f prime is less than 0 on that interval. Right, let's come over here. Let's do our relative max. F has a relative max at x equals negative 1. And I know that because f prime changes from positive to negative there. All right, and so I said the word there just now, which is, again, that's acceptable, but I'm going to be a little bit better than that. I'm going to say positive to negative at that point. All right, one more thing I want to verify is, do I have to identify the y value? So identify all points that are relative maximum and minimum points. So I think I should find the y value of these as well, because it didn't say identify all x values that are relative maximum and minimum points. Okay, so let's spend a minute here finding the y values of those two. So I'm going to plug these numbers back into the original equation. So f of negative 1. All right, so that's 1/3, and then negative 1 cubed is negative 1. And then minus negative 1 squared is positive 1. Negative times a negative is a positive 3 plus 2. So this is a 5 minus 1 is 4, and I need to get it over 3 for a common denominator. So it's negative 1/3 plus 12/3, which is 4. So that's equal to 11/3. All right, then I'm going to do f of 3. So 3 cubes 27, divide by 3 is 9. Minus 3 squared is 9. Minus 3 times 3 is 9, plus 2. So 9 minus 9 cancels, and I have negative 9 plus 2, which is negative 7. All right, so f prime has a relative max at, I'm just going to cross this out, and I'm going to write the point at negative 1 comma 11 thirds, because f prime changes from positive to negative at that point. And then f has a relative min at 3 comma negative 7, because f prime changes from negative to positive at that point. All right, last thing they asked us to do was to use our results to sketch a graph. So I left some space here for that reason. All right, so we now have 2 points. We have a negative 1 and 11 thirds. So negative 1 and 11 thirds is a little bit less than 4. So right there. And then I have a positive 3 and negative 7. Okay, then our function is increasing on the left side. So we're going to start low and we're going to increase on the left side up to this point, then decreasing in the middle. So we're going to decrease down to this point. And then we're back to increasing again on the right. So back to increasing again there. So our function will look something like that. If you're familiar with cubic functions, you will know that that is, in general, what a cubic function looks like. And so we have our graph there. Okay, we're going to learn some more stuff in a later lesson. We'll be able to create even more precise graphs than what we just did right here. But this is a pretty good start for being able to sketch a curve without a graphing calculator. All right, so this is not a function you would have been able to graph very well back in even pre-cal or algebra 2 without the help of a graphing calculator. All right, so you can see how calculus can help us do that. One thing I want to point out is with our justify your answers. A lot of people are going to say, like, we did this whole number line. Doesn't this have all the information here? I drew my arrows. I wrote max and min. Can we just say, boom, there's our answers. That's our justification. All right, the answer is no. The AP exam has specified that this only counts as scratch work and will not be accepted as your justification. So I'm always going to do this because that's a very nice visual. It's a concise way to show our work and to refer back to every time we're writing this. But you have to write these statements out to be able to get the credit on these problems. Okay, I will say that you're never going to have a problem that's this big. Okay, so a problem might just say, find all the intervals where f is increasing. So you're just going to have to do one of these. That's why I'm having us write out the entire sentence, because it's just not going to save you that much time to abbreviate a bunch of stuff. Okay, you don't want to risk losing a point because someone doesn't understand your abbreviation of something. Write out all the words and you will definitely earn all the credit. Write your answers so perfectly that they have no choice but to give you the points on the problem. All right, over on the back, let's do one more. Okay, so we have this function. We're going to take the derivative, increasing, decreasing, maximum, minimum. That means do the derivative. 2/3 times x squared minus 4 to the negative 1/3 multiplied by 2x. All right, I recommend rewriting your derivative. So we have a 4x on top, and we have a 3 times x squared minus 4 to the 1/3 power. All right, so remember, critical points happen anywhere our derivative is equal to 0. So you set 4x equal to 0, and you get x equals 0. But also anywhere where the denominator, where the derivative is undefined. So that's where the denominator, and you can just take this part inside the parentheses there, anywhere that's equal to 0. So that's going to be at x equals 2 and x equals negative 2. Okay, those are critical points as well, because the original function is never undefined. A cube root has all real numbers as its domain, and if you square something, that's all real numbers as well. So the original function's domain is all real numbers, but the derivative's domain excludes these two values. So we have to include those as critical points for this problem. All right, once you've identified your critical points, you make your number line. -2, 0, and 2. Then we're going to test points in each region for f prime, and that's going to let us know what's happening with f. All right, so we're going to do -3, and I'm going to plug it in here. So -3 would give me a negative on top, divided by negative 3 squared would be positive 9 minus 4 is a positive number. So it's a negative divided by a positive, which is a negative. All right, negative 1. That's still going to give me a negative on top. Negative 1 squared is 1. 1 minus 4 is a negative number. So that's now going to give me a negative on the bottom. Negative divided by a negative is a positive. Okay, I'm ignoring the 3 here because it's a positive number. And a positive times a positive is a positive, or a positive times a negative is a negative. So whatever the sign of this thing is going to determine the sign of the entire denominator. Also, I'm ignoring the exponent because it's an odd exponent. Odd exponents keep the sign of whatever's on the inside. So just whatever's on the inside here is going to determine the sign of the entire denominator. All right, let's plug in positive 1. That's going to now give me a positive on top, but 1 squared is 1. 1 minus 4 is a negative. Positive divided by a negative is a negative. And then 3 is going to give me a positive on top. 3 squared is 9. Minus 4 is a positive. So positive divided by a positive is a positive. All right, so what's happening with f? F is decreasing, decreasing. F is increasing, F is decreasing, and F is increasing. That makes this point a minimum, this point a maximum, this point a minimum. All right, let's write out our justifications. F is increasing. On, let's see, negative 2 to 0 and 2 to infinity, because f prime is greater than 0 on those intervals. F is decreasing on negative infinity to negative 2 and 0 to 2, because f prime is less than 0 on those intervals. All right, for doing maxes and mins, we need the points. So let's plug these numbers in. F of negative 2. So negative 2 squared is 4, minus 4 is 0. F of positive 2. 4 minus 4 is 0. F of 0 is 0 minus 4. So that's negative 4 to the 2/3 power. If you want to go ahead and square that, negative 4 squared is 16 to the 1/3 power. Okay, there's not really much you can do with that. 16 is not a perfect cube, so we can leave it like that. You can write it in simplified form. Let's just leave it like that. I think that'll be easiest. All right, so F has a relative max at 0, 16 to the 1/3 power, because f prime changes from positive to negative at that point. And lastly, f has, not a, because there's 2 of them, f has relative minimums, maybe minima. I'm going to go with minimums at negative 2, 0 and positive 2, 0, because f prime changes from negative to positive. At those points. All right, so I think we found everything that we've been asked to find. They would say to use our results to sketch a graph, so let's do that over here. Again, having this number line graph makes things pretty simple. Negative 1, negative 2, positive 1, positive 2, 16 to the 1/3 power. Let's think. 8 is a perfect cube. So 8, cube root of 8 is 2. And then the next one would be 27. So it's somewhere between 2 and 3. So 1, 2, 3. I think it's a little closer to 2, right? 16 is a little closer to 8 than it is to 27. So say right about there. Right here, let me graph in a different color. So right about there, and then these are both at 0 here and here. All right, so the function is decreasing. So decreasing down to here. Then it's increasing up to this point. Then it's decreasing again down to here. Then it's increasing the rest of the way. And so there you go. And this is a function that you definitely would not have been able to graph. You wouldn't have been asked to graph this in previous classes because of the weird exponents. But with calculus, we can pretty easily create a nice graph. If you plug that into a calculator or into Desmos, you'll see that it looks pretty much like this. Again, we'll learn some more stuff in a later lesson this unit where we'll be able to create an even better version of this graph than what we just did here. But this is a pretty nice little sketch just by finding a couple of interesting points and finding about increasing and decreasing. All right, hopefully you enjoyed that. I will see you on the next lesson.